Hi everybody! So in this video we are going to learn about something called LHopitals Rule. I reminded you at the beginning of this unit that limits were coming back. So let's start by reviewing how to evaluate these limits using the techniques that we studied at the beginning of the school year. The first thing I know about limits is that I should always try to plug in my value. In problem number 1, if you try to substitute the number -2 into this equation, on the top we get 0. And on the bottom we get 0. Since the denominator is 0, we cannot just use substitution to simplify this limit. So we said the algebraic technique that we would try would be factoring. When I factor the numerator of this problem, I get x plus 2 times x plus 1, and the denominator does not change. Because the x plus 2 is on the top and the bottom, those would cancel. So my simplified limit would be the limit as x approaches -2 of just x plus 1. Now, if I retry substituting my value into this simplified limit, the value that I get is just -1. For problem number 2, if we try substituting our number, then in the original problem we get 0 over 0. And since you can't divide by 0, we would say that we needed to do some algebra to figure this out. So in this problem, I would probably try multiplying by a conjugate. As a reminder, the conjugate would be the square root of 1 plus x plus 1 over the square root of 1 plus x plus 1. When you multiply on the top and the bottom by that conjugate, on the top, because they are conjugates, we just get 1 plus x minus 1 over, and on the bottom I would have x times square root of 1 plus x plus 1. On the top now, 1 minus 1 cancels, and because those are gone, now we can cancel the x and the x. So my simplified limit would just be the limit as x approaches 0 of, since there's nothing left, just 1 on the top, and the square root of 1 plus x plus 1 on the bottom. Now I would retry substitution, and I would end up with 1 over the square root of 1 plus 1, which is 1 over 2. Now, what we're going to talk about today is that we have a new strategy for simplifying and evaluating these kinds of limits that does not require us to do all of this algebra. If you try substituting your number, plugging it into a limit, and you get either 0 over 0, which is what we got in these first two problems, or infinity over infinity, we call those indeterminate forms. Which means the value of the limit cannot be determined by substitution. Then what this rule, which is called LHopitals Rule, because it was discovered by a man whose last name was L'Hopital, is that you can take the derivative of the top and the derivative of the bottom separately and try again, which means you can try substituting. You can repeat this process until you no longer get an indeterminate form. What's really important here is that we need to show our work in a very precise way to be able to use this technique in order to communicate our thinking and what we did. So for this example, the first thing I would do is try substituting. Now thinking back to the unit circle, if you substitute in the value 0, on the top the value of sine is 0, and on the bottom you just have 0. It is very important that you actually show the indeterminate form before applying L'Hopital's rule. So showing that you get 0 over 0 like this is required as part of your work. Then you need to say that this led us to be able to apply L'Hopital's rule. On the AP test, if you don't specifically state that you used LHopitals Rule in order to simplify this limit, they will not give you full credit for showing your work. So saying the word LHopitals as a result of establishing your indeterminate form is really important. What LHopitals Rule says is this: we can take the derivative of the top, which would just be cosine of x, and separately take the derivative of the bottom, which would just be 1, and then try to substitute again. If you take the 0 and you plug it in for the x on the top this time, on the unit circle, the cosine of 0 is just 1. And since the bottom is just 1 also, your evaluated limit would just be 1. Let's try this again. So this is the exact same problem that we did at the very top of this paper. We've already established that when you try plugging in the number -2, your answer is 0 over 0. Because that is one of our indeterminate forms, our method of choice here will be to apply LHopitals Rule, which means we're not going to need to factor this, or we're not going to need to factor this time. We would say that the new limit, which will give us the same answer as the old limit, would just be the derivative of the top. So instead of factoring it, I'm doing the derivative. I would have 2x plus 3 over the derivative of the bottom. The derivative of x is just 1, and the derivative of 2 is 0. Now I would retry substituting. So I would take my -2 and plug it in. 2 times -2 plus 3 would just be -4 plus 3, which is -1. And what you'll notice here is that we got -1 as our result by factoring as well. So taking the derivative is going to give us the same result that we would have by getting an algebraic technique. Problem number 2 is again the same derivative, the same problem that we did up above. We're just going to do it now in a new way. If we substitute in our 0, we get 0 over 0, which means it is safe to apply LHopitals Rule. So the new limit that I'm going to try to find, I'm going to take the derivative of the top and take the derivative of the bottom and try again. On the top, I like to think of this as really being 1 plus x to the 1/2 power. So the derivative on the top would be 1/2 times 1 plus x to the -1/2 power. Since the derivative, the chain, would just be 1, I'm not going to worry about writing down my chain. Now, I also need to take the derivative of this -1, but that just gives me 0. The derivative on the bottom would just be 1. So I did the derivative of the bottom and the derivative of the top separately. I'm not using things like quotient rule here, which is really nice. I'm just doing the derivatives separately. Now I would retry substituting in my value. So if I come up here and I plug in the number 1, I'm going to get 1 plus 0, which is 1, and 1 to the -1/2 would just be 1, because 1 to any power would just be 1. So my final answer here would just be 1/2. What you should notice is that that's the same thing we got by multiplying by a conjugate. But to me, this is a much more straightforward way of doing this because I'm familiar with taking derivatives now. For problem number 3, we're going to try this one. This is not one that we've already tried. So if we plug in the infinity here, e to the infinity is just infinity, and 2 times infinity is also infinity. Now, infinity over infinity is another example of an indeterminate form. So since we got another example of our indeterminate form, we're going to apply LHopitals Rule to simplify this limit, to evaluate this limit. So what I would do is I would do the derivative on the top, which is e to the 2x times 2. And I would do the derivative on the bottom, which is 4x. Now I'm going to rewrite this in a way that's just a little bit neater and more organized. So on the top it's just going to be 2e to the 2x, and on the bottom I'm going to have the 4x. Now when I retry substituting, I get infinity over infinity again. So I'm going to apply LHopitals Rule for a second time. The nice thing about LHopitals Rule is that we can continue to apply this rule until we create a limit that does not give us one of our indeterminate forms. So my new limit here would be the limit as x approaches infinity. On the top, my new derivative would be 2e to the 2x times 2 again, because I still need to apply the chain rule for a second time, over, and on the bottom, the derivative would just be 4. Now, when I substitute in my value, I'm going to get infinity on the top and 4 on the bottom. And since infinity divided by 4 is just infinity, it's not an indeterminate form anymore. Therefore, my answer is just infinity. Now, one thing that's a little bit something to kind of be cautious about or careful about in this technique is that we can only apply LHopitals Rule if it is one of these forms. So here's a common mistake. Some students will come to this problem and they will say, I plugged in the number 2 and I got 3 over 0, which means I'm going to apply LHopitals Rule. However, 3 divided by 0 is not one of our two indeterminate forms. So what we need to do here instead is fall back on some of our old derivative techniques. In order to check the limit as x approaches 2, I'm going to need the limit as x approaches 2 from the left of 3 over x minus 2, and I'm going to need the limit as x approaches 2 from the right of 3 over x minus 2. And again, I'm doing this because this is not an indeterminate form. If I imagine plugging in a number slightly less than 2, like 1.999, I'm going to have 3 divided by a very small negative number, which means I'm going to get negative infinity. And if I imagine plugging in a number a little bit bigger than 2, I'm going to get 3 divided by a very small positive number, which means I'm going to get positive infinity. Since those limits don't match, I would say my limit here does not exist. One thing to be very careful about is not to apply LHopitals Rule when it is not an indeterminate form. Thank you guys so much for watching and have a great afternoon. I will see you tomorrow for some practice.